I always said that if the ARC challenge got beaten, that I would update massively, and it has been beaten, and I have updated massively. With some reservations, I'm still slightly concerned that there could be some dataset contamination. We don't know exactly what they did to fine-tune on ARC, so there are some questions that remain unanswered. It's quite a classic thing for OpenAI to announce incredible things, and then, just like with Sora, 9 months later, you get the shocking reality unveils itself. But with that said, it feels different. It feels like it's an example of true developer-aware generalization, because you can see that they are basically one-shotting it transductively. So in solution space, you can see their prompt template. They just give it a few candidate specifications, and it can apparently produce remarkable performance, albeit with an insane amount of computation. So I guess we'll wait and see. But what do you guys think?
Yeah, I think it's quite impressive that they manage to do that without any kind of test time retraining like we do. So that the model can do it in one shot. I think it's very amazing.
I think it's also crazy. We are like all ARC people, so we are focused on the ARC dataset, but they also have crazy performance on different data benchmarks. The one that impresses me most is the frontier math benchmark, where they get 20%, as far as I know, and I 25%. Yeah, I get 0, so it's a little bit annoying. It will be really interesting to see it when it gets published, and 2 years down the line, when probably, if the trend holds, the open source models get the same performance. It's going to be scary. Yeah.
What I do not see yet is how it kind of it tackles reasoning well, apparently, but some of the kind of inherent weaknesses of LLMs are still there, right? Let's say hallucination or so. I don't see yet how kind of a Node 3 addresses these issues yet. It could be like with self-correction or so, but I don't know how they really do it. But probably nobody knows so far.
We now seem to have second-order hallucination. So I notice O1 Pro, it hallucinates from the reasoning trajectories, which is, and it's even more insidious.
Yeah, and I think that's very hard to detect. One could do it with a meta model, but yeah, I don't know.
So you previously said that initially you were very impressed with the 3, and then not quite as much. So what caused that adjustments?
That they used the training data of the ARC to fine-tune. Like I thought it was like really true zero-shot training, and then I was on the floor. Now it's clear that they use a little bit of the training data at least, and it's slightly less impressive. And they also use a lot of compute, and also slightly less. It's still crazy. Don't misunderstand me, but it's not out of this world crazy. Like I can imagine that you can get there from my current perspective.
But it wasn't unfair, because Gary Marcus went off on one, saying that it was scandalous that they trained on the training set. And of course, it's completely legitimate. What interests me is that Cholet has made a career out of being the critic. And even he has not fallen on his sword, but he is not his usual self. He does genuinely believe that this is a major breakthrough in generalization, the extent of which, of course, we'll find out.
How did it look like your process of updating? Because initially you were on the with Cholet thinking that like we need programs. This is program induction.
So Cholet's position is ambiguous, because he still thinks that this is not an LLM. As in, it's an LLM, but it's some kind of a search controller. So as far as he's concerned, this has proven him right. If it turns out to be a simple, autoregressive single forward pass of an LLM, I think that wouldn't look good for him. But the main thing for me, though, is I always thought it was impossible to do solution-based prediction. I just didn't think it was possible. So I always thought we need to have a program, because programs have all of these features that we know and love, compositional generalization, and they run on Turing machines and so on. I never thought that these things could actually make strong generalizable predictions in solution space. And when you look at the failure modes on O3, if anything, it seems to prove that they do understand. In some of the failure cases, they actually made more correct predictions than the true labels. In other cases, they made slightly kind of, off by one type errors. And also they degraded when the solution space grew too large, which seems like something that can be fixed over time. So if anything, the evidence is pointing to them working very well at reasoning. What do you think?
Well, like you said, that the LLM gets extended in a way in O3, right? There's some type of algorithm that goes around it that produces the chain of thought sampling, and it's something we have also seen in our approach, right? We have a LLM model at the core of our approach, but a lot of our score increases came from using external tools to extract information from the LLM better. Like the LLM's smart, it can give us a very good probability for the next token, but on its own, it's not enough because we don't have good sampling technology at the moment. So we had to add a lot of complex parts afterwards to get it to produce the correct solution. And I think you can substantially increase performance in LLMs a lot of times by just having a smarter algorithm behind it that checks the results in a way.
Yeah, that's really interesting that you said that they had the capacity to understand these problems, but just, it's quite interesting, isn't it, that you can ask an LLM to discriminate. Generating is more difficult, but even more difficult than that is traversing the token space between pockets of good things. So what these guys did in their winning solution was they essentially had to, rather than using this stochastic sampling, where every single token you just do this minimum entropy search essentially, that you design this depth first search where you had to kind of traverse many bad steps in order to get to a good step. But when you actually found that part in the token space, you could actually kind of ask the language model, do you think that this is the correct program? And then it would give you the correct answer. So the problem was traversing there in the first place.
Yeah, in some way it was. So sampling is an approach that essentially did work too on ARC, but it wasn't that efficient. So if we have a correct solution that we need to find, which has only 10% probability to be predicted during sampling, then we had to sample quite often to find it with some chance. And with the depth first search, it's essentially a way to search through all possible candidates with a sampling probability above some threshold, and to do it very efficiently. The LLM just predicts token by token, and we can essentially do a tree search in that prediction. We predict the first token, we get a probability, and then we go further, and on our path we sum up the probabilities, the log probabilities of all the tokens as a measure of the probability of sampling this completion. And that's actually where we cut off at some point. If we fall below a threshold, we say this is not promising. We go back and we search for other solutions. And this way, you can essentially find a lot of good candidates. And we hope that the correct solution is within them with this process.
It's a very problem-specific solution because in language tasks, the probability of any completion is quite low, just because there are so many possible completions.
So many completions that are essentially all valuable, all good for language.
But in our case, we only have one correct completion,
one.
right? Yeah.
One solution that
to be
is
clear,
correct.
in your approach, there is a direct mapping between a pixel and the grid and tokens.
Yeah,
Exactly.
We just tokenize essentially line by line, but with numbers from 1 to 9. We have an end of line token and an end of sentence token for the end of the prediction. That's essentially the tokenization method we use.
And you were saying that in natural language, it's quite interesting to think about the reachability space, like, in language models. These guys at Toronto I interviewed, they came up with this Roger Federer game, which is where you need it to say greatest. So Roger Federer is the greatest. What prefix can I come up with to make it say greatest? And it turns out that if you have a large prefix budget, you can make it say greatest. In fact, you can steer the model to say anything you want. But in natural language, the token space, because it has many more degrees of freedom, right? Because language is kind of weird and gnarly. But on something like the ARC challenge, there are not many degrees of freedom. and there are hardly any trajectories. And so the challenge is just finding that trajectory to get to the solution.
The probability we talk about, like the completion probability, is just the sum of the logits of the tokens, right? And in natural language, if you can have 10 sentences that all mean the same thing. So they can't have the correct probability if you think about the concept. Like the concept has to have the sum of the 10 completions, but each completion is obviously lower, right? In the ARC contest, because our completions are so restricted in the token space, right? We have only one correct path, and then there's a large alignment between the probability of this specific completion and if the model thinks that it's the right completion. And we could leverage that to not only evaluate a completion from one perspective, but then also shift perspectives, right? The augmentations, evaluate it again, and then calculate the product of the probabilities, basically, to select our right candidate.
I interviewed Randall Balistriero at NeurIPS, and he's got this interesting research that, we think that we need to have these pre-trained massive language models that, know about everything on the internet. And if you're doing discriminative tasks, you can start from scratch because the models, even from a blank slate, they have all these inductive priors and biases and so on, and they just work out of the box. So on simple tasks, you can just do a little bit of training on a llama, style model, obviously not pre-trained, and you can do really, really well. And you guys found a similar thing. So I think you suspect that even if you started from just a blank slate transformer, fine-tuning it on the specific ARC challenges actually moved the needle significantly more than any transfer from the base data.
We didn't try it.
Not yet.
We actually don't know.
Yeah.
It's just something everything one says, the concepts come from the language that the model have learned and they are just applied to ARC. But I don't know if everyone has ever tested if this is actually true, or if we just start with a blank slate model and train it on ARC. How well does it perform? Something we want to try out. Yeah. But we haven't gotten to it yet. Yeah.
Now that I think I understand your approach, would you mind explaining why you think you achieved 0% on frontier math? Because I think math is very similar where you have very sparse good candidates, right? There's only so many formulas that are inherently correct versus natural language, there's a lot of combinations.
No, I think that was a misunderstanding. I, as a person, can get 0% of frontier math, yeah? I'm stupider than llama, so it's... Yeah. But
I still think it would be difficult for the model because in math there's still a lot of completions. There's still a lot of ways to write a formula. If you write a plus b or b plus a, that's essentially the same problem as in language. So this approach would probably not work that well without a lot of additional tuning.
That's a research idea we are looking into, actually. Yeah.
Okay.
Yeah.
So what's your current best guess for what 01, 03 look like architecturally? Like what are they doing at training time? What are they doing at inference time?
I'm not sure. I personally think it's just RLIF trained GPT-4 model that has some very smart training data. It's a possibility I think about. Like we had a lot of discussion about it today, and there are different thoughts about it, but I see, for example, do you know the QWQ model from Alibaba? It's also a thinking model. It's okay. It's quite good for an open source 32B model. And I think they just train on tree of thought completions. Like they do a tree of thought for a specific problem. They check if it's a good solution, and if yes, then they reinforce it. And it might be everything that O1 is doing, or they have like a more complex backend. It's also possible that they do some very, very smart tree of thought in the background, which we never see. We don't know.
How do you think that you do the verification? Is it like hand-coded, or is it a model to verify whichever chain of thought is correct?
I think the standard theory of thought approach uses a verifier, or the best theory of thought approaches I've seen. They use a verification model. But
is that a separate model?
Yep.
Do you think?
Yeah. It has to be because a model is bad at verifying its own outputs, right? Yeah. That's also what we saw in ARC. We couldn't just take the probability on its own because it would just be the probability. We had to shift the problem the model sees to get a good evaluation of if it's correct.
Or maybe it's just that poor people's models are bad at verifying the outputs, and when you're GPU rich, you can actually verify your outputs with the same model just fine.
just more data.
How different has the verifier model to be?
I don't know. I have no idea.
To be like.
Yeah.
So what does it look like in the case of your work on ARC? You said that you use a different.
No.
Yeah,
In our case, it's the same model,
Okay.
but
Okay.
we change the problem, basically, because the problem has a very nice structure. You can just rotate the problem, and then ask the model if you see it now, is it still the correct solution? You know.
And if you ask it for all rotations, transpositions, and something, for some the model will detect essentially that they were wrong and output low probability. So if you multiply them, essentially get a good selection process there with using the same model.
So I guess as a follow-up on the inference and architecture question, they're spending, according to their own numbers, like thousands of dollars per arc task. I'm sure that's an average, but like there's only so many ways to spend that much money on a single forward pass, essentially, right? So like that's a load of GPUs, a lot of power. So they need to be doing something, right? It needs to be doing something. Like what are they doing? Like it needs to be branching out a lot, and you can only have context that large. Like what's your guess? Which way are they scaling? Are they just scaling all the ways?
I think the cheap one was $6,700 for all 400 arc tasks.
17 per task on the evaluation.
$17 per task.
I think 280,000 token or something like that.
Yeah.
So that's quite a lot. And I don't necessarily think that was in one forward pass. Maybe they did.
Oh yeah, for sure, many. But I'm just saying, like that's what they're doing, right? Essentially, it's doing forward passes somewhere. So you need to be doing like shit tons of forward passes, even if you have a lot of GPUs. That's
several books worth of text that I produce, and if you have thought that long about a problem, then you better solve it. Yeah. But it might be, at the moment, my guess would be that they produce intermediate results, because each arc challenge uses an annoying amount of tokens. Like if you have a 30 by 30 grid, you need 900 tokens at least to just print it. So maybe they just have like a thinking process that also produces intermediate results and then evaluates them, you know, and then just repeats until it thinks that it has found a good solution.
Could also imagine that they let the model reason, give them the example, just let the model reason what the actual task is, what the transformation rule is, and then ask the model itself to apply it to the data. So maybe something like this, and then iterative refinement or something like that. Yeah.
That would still be a general procedure, though, right? I mean, we know the prompt, so it's not in the prompt, unless they're lying.
Yeah, no, it could be very general, like that you separate the problem into smaller steps, think about these steps, apply these steps, and then just repeat until you get to a clear result. But nobody knows.
Well, some people know. They're just not saying.
Yeah, there are some hints on Twitter. I think Rune and a few OpenAI employees, and I misinterpreted their tweets. Just to be fair, by the way, I originally thought it was just a single forward pass because I was looking at the Google thinking model and QWQ and so on, and they are a single forward pass. But they don't do much thinking. And I just know from experience that, to get coherent anything for a long period of time, it's very, very difficult. And these things are thinking so much. What they said on Twitter was that it's all one model. And I believe that. I think it is. I think the model goes into a mode and they can do this tree search in that thinking mode. Because per Cholet, what's actually happening on the final unroll is you give it in the prompt a chain of thought program. So the search process is about finding what is the optimal program, which if I prefix this on my unroll, it will solve the problem for me. It comes back to that what's the magic word paper that I was just talking about before, that there's almost like a secret key that if you prefix the language model with this magic sequence of tokens, it'll do the thing you want it to do. So it's about finding that. We all agree at training time it's doing something like STAR, the Noah Goodman paper, right? So it's doing some kind of process supervision. It goes into a mode, they do this kind of tree search, and I guess what they're doing is they're just trying to find the best possible chain of thought prefix. And then when they find the best prefix, given their computational budget, they stick it into the same model and they just unroll. And I think that's what they're doing.
So why does no one else do it that way? Like, why is Gemini so far behind?
Well, that's interesting that they say the headline metrics are very good doing it the way they are doing it.
Well, they say many things. Yeah.
But I think part of that is just having a model, trained with this STAR approach to imagine the best possible train of thought and then just immediately running on the first chain of thought you came up with. Apparently, even that gives you a lot of uplift. And I'm guessing just optimizing on that chain of thought program before you unroll is even better.
Can I ask a related question? Just what's your personal take? Who's going to be the best reasoning model end of 25? And who's ready to put down money?
I think it's a little bit of a... I think the main difficulty of this question is just in which iteration we are at the moment. Like, it's always... OpenAI is always, almost always at top, and then the other companies sometimes like spike above it, and 1 month later OpenAI takes over again. So if we are in the 1 month spike where OpenAI loses, then not OpenAI, but most probably OpenAI.
There's something magic about Sonnet. Something magic about it. I can't quite put my finger on it, but it just has the vibes that no other model has, you know, for a base model. Something magic happens when you do this thinking mode. The models take on an entirely different character, but a bit of a soulless character. You know, they have some interesting properties, like, you know, now they're more creative because they've considered different options and so on. So they're not as pointillistic, but they have no soul. Anthropic has this character to it that I've not seen anywhere else, and I'm very excited to see what happens when they drop their newer, better Sonnet and with the thinking on the top.
I'm curious about DeepSeek as well. I expect them to do well, maybe not at the top, but put out a good model.
But that was the context, though, that apparently DeepSeek, while it does well on headline metrics, it has no soul. Yeah, there's this guy called, you know, the guy who wrote the simulators paper, Janus, and he's a full-time prompt whisperer. So he just talks, he obviously thinks the models are conscious and all this kind of stuff, you know. But no, he like understands these models in a way that no one else does. And he just said that DeepSeek is like basically soulless.
I mean, that's science, folks.
A very common thing you observe if you sample a lot from an LLM is like it mode collapses or it's actually not very diverse. And I would expect that you need that diversity to for that error loop, like in the star, if you have a star-like process. So where do you think that's a problem in practice, and where do you get the diversity from?
If you have several models, you can just take each thought, embed it like in a vector space, and then check if it's too close, and then discard it and do a new one, right? Like, there are always engineering solutions, but if what you say is true and they just use a single model, then it's just trained very well, right? Then it just is good at outputting creative and new ideas in the thinking process.
Or maybe having kind of long enough thoughts, right? Whereby the thought processes might be noisy and then you might get out of your local limits, right?
The way that the chain of thought works right now is just internal, right? Internal to the model. But obviously, like, you can do other stuff while you're thinking. But OpenAI has made the product and competitive decision for now to just keep all that internal, right? So as soon as we add what they call function calling, tool calling, whatever, to that loop, it's like going to shift the advantage to more open source models. Like, what do these systems look like in your mind, having built something like it?
My spiciest take is that I don't think that chain of thought is the right approach. So when humans think, right, we have an idea of the sentence we want to speak before we speak it. And then we try to find the words that communicate this idea. And a language model try to externalize memory or thinking into words at the moment. Like the chain of thought process is basically just, we need some type of memory where we can write down thoughts. And there are some approaches at the moment. I think Meta has a really nice paper, LCM, I think, where they, yeah, exactly, where they try to move from the discrete token space into a more continuous space for thinking. And I think if you can get that to scale well, it's a far superior approach when you have just arguing in the concept space instead of having to default to discrete words, you know?
Yeah, but it's not words, it's tokens.
Yeah, that's it, yeah.
But you're still missing kind of state representation, right? Kind of an internal state. That way, right? You just still, like, to me, it doesn't really, like, significantly change something compared to the standard chain of thought, right? It's just like the way how you present your thought, kind of in a continuous state, but by itself, it's still kind of a chain of tokens, whatever.
So I agree with that. And the neuroscience is very clear that in humans, thoughts precedes language. Like, you can lose your language area and you can still do like logic kind of tasks. But for example, the byte-transformer results are very lackluster. So is there something else that we're missing? Yeah, what does that tell you? Like, is that actually a problem? Is what I'm thinking.
We have a lot of language to train on. We have not a lot of thought data to train on. Like, it's just accessible. Like, if you can train on the whole internet as tokens, how would you even train that? Is the problem, I think. Like, you can't do a normal gradient descent on intermediate steps. You know, that makes it very hard.
Yeah, I guess maybe your best bet is like some RL type approach, maybe similar to one where you get to do your own thinking and reinforce the good type of thinking, but that requires a kind of a self-play loop that is making you improve. And maybe we don't have that.
How much do you think we can compress the reasoning output that we're currently doing, like outside the model, basically, we just feed it back inside the model? And that seems to be something that Sonnet 3.6 or something is doing in a way, right? Because in essentially one forward pass, it does a lot of stuff correctly that O1 doesn't, even though it has more thinking time. So there must be some translation function where you can map and spend money maybe on reasoning, but then actually training the model on that reasoning. So I guess the question is, to what extent do you think that works?
We discussed this earlier. I mean, with your system on Arc, at the beginning, you need to do lots of thinking, but you just continue to fine tune. And over time, it doesn't need to do thinking anymore because it just knows. And I can imagine that the reason why Claude's model works so well is because they've already done something not too dissimilar to this thinking process in their pre-training, and it's already internalized a lot of common thinking.
I mean, that's the hot take on Twitter, right? They have had Opus allegedly for months, but they're just not releasing it because there's no point. They're just using it to improve their cheaper model in exactly that way. It still doesn't answer my question, though, which is, to what extent does it work? Like, how much can we scale that up?
It should be able to, after it's done a bunch of thinking. I mean, this is part of my suspicion on why the O1 and the O3 model works so well, right? Because everyone's been throwing lots of ARC data. I mean, we did debate this because they're not technically supposed to use data from the API to fine-tune on, so we don't know for sure.
What about frontier math? Like, it's also good at frontier math, and I don't think there's been too much frontier math thrown around, right?
Yeah, it's so hard to know with the dataset contamination. By the way, you made an interesting comment about open source. So there's always this question with language models of how much do you actually need the base language model to be able to do things out of the box versus the practicality of fine-tuning it to do some specific thing you want it to do. And it turns out for most, most stuff that we're going to build in the real world, we need to set up these complex bespoke architectures where we fine-tune it to do very specific things. So then what's the difference between a frontier model and something like, like Llama? So there seems to be like two worlds at the moment, that there's, the OpenAI dream that we have this general intelligence that we could zero shot absolutely anything and it can do thinking, versus the reality of building enterprise apps where we need to do a lot of work and it's quite bespoke.
Well, which dream do you believe in?
Well, I would love it if there were such a thing as a general language model that could just do thinking and figure things out, zero shot, developer-aware generalization. But I don't know. It seems to fly in the face of a lot of our practical experience.
It's also a crazy time, like benchmark after benchmark gets beaten by LLMs, but we still don't, obviously, like you can just look at it, it's not what we mean when we say general intelligence. Like it can do amazing stuff. In many ways, it's smarter than almost any human I know. Like the LLMs are good at the stuff they do, but they don't feel like a general intelligence, right? And I'm wondering if it's possible that we live in a world in a few years where we can't find any benchmark that is not immediately beaten, but we still don't have the general intelligence we want. If that is even possible.
Yeah, that'll be the sad thing, is when O3 comes out and we all have this like horrible moment where we think, oh my God, solving ARC didn't actually make any difference. Like we're still stuck. The only thing that I really have updated though, because I'm using ChatGPT Pro and it's genuinely unreal. I'm using it every day and absolutely everything I use it for is just dramatically better than any. We were saying like earlier that, the way we judge the vibes of intelligence is quite relative. So it makes Sonnet look dumb, and that's insane.
Doing what?
Oh, I mean, I can give you a list of things, whether it's generating code. I mean, like last night, for example, I accidentally deleted the table of contents for Cholet. So, and I generate it with Anthropic. I have to tile it like recursively, otherwise it's just terrible. Just zero-shotted it with ChatGPT Pro. It just produced the best table of contents I've ever seen in my life. It did actually hallucinate for other reasons. We talked about that, but like when I took out the hallucinated lines, it was just ridiculously good. And not only that, you can just stack up, I've always had this mindset of using language models that you have to partition a problem into smaller subproblems because there's a computational budget. There's only so much stuff that you can do. So, we have this intuition about how we partition problems and do engineering and so on. With ChatGPT Pro, because it's got like this variable amount of computation, you can just give it 5, 6, 7, 8, 9, 10 things. And within reason, it'll just do all of it and it will just give you the result when it's done. And that's a completely different behavior than we've ever seen from language models before.
If you say ChatGPT Pro, what is the underlying model there?
Well, we don't know for sure, but I assume it's the GPT-4o model. And I'm guessing that the O3 has the base of the Orion model, the 4.5 or the 5 model.
So it just says like ChatGPT Pro, but you don't have a drop-down selection of what model, and you just get more.
It does say O1 Pro.
O1 Pro.
Yeah.
Yeah, that's
Yeah, O1 Pro. But the amazing thing is just how the character changes. Because I think GPT-4o is a dumb model. It's always getting better though, so it's less dumb recently. But it's a really dumb model. I hate the style of it. I hate like the delving and so on. But I just think it's a dumb model. And what really just blows me away is how doing this kind of thinking process changes the character of the model. It feels like a completely different model in character, even though it's based on something, that we know. And it's the same thing, you can add thinking to like, Llama 1 billion model, and it behaves as if it's a Llama 8 billion model.
So how much difference do you observe between O1 and O1 Pro?
Absolutely huge difference.
So that's surprising because they said it's just the same model with more compute.
Yeah, so O1 doesn't want to think. So usually it thinks for about a second, and I'm guessing they're doing that just to kind of get people to upgrade to Pro. So it thinks for a second or two, but ChatGPT Pro, sometimes you can get it to think for about like 12 minutes. And that's actually really annoying when you're programming. But another interesting fact, by the way, is that part of the reason it seems better at programming, I wonder whether they've done this on purpose, because you can't use it through an API, so you can't use Cursor, because most of the failure modes on Cursor are the apply model. So when you're actually forced to take the code yourself and manually copy it back into VS Code, like it actually works, because obviously, the apply model from Cursor hasn't messed up. Another thing is the apply model in Cursor is now better. They've updated it with a version that does like 5,000 tokens a second, and it doesn't delete your code quite as much, only like 2 out of 10 times.
What's your observed correlation between thinking longer and actually better outputs? Like, is there a point at which it starts to just degrade again?
I can't say I've noticed a correlation, but other than more thinking, better. But whether there's some kind of, I don't really know.
You said you're going to be very sad if the ARC benchmark is going to get beat and nothing changes. What do you think the ASI benchmark is going to be the new thing for people to beat? Is there something already forming in very certain Twitter spaces? What's the next cool thing to work on that we can already...
One thing I want to say is I would be sad if frontier math gets beaten and nothing changes. Right?
There are a lot of different problems. Like obviously the next ARC iteration is dropping soon. There are a lot of other interesting problems. Like at the moment there's a Kaggle contest for AI Math Olympiad, where you can use up to 32 B models, and the only goal is you get the math questions and you should output the correct answer modulo 1000. And I think at the moment, the top scoring model does 24 out of 50 problems correctly, which is good. But I don't think they would beat the frontier math benchmark at all. Otherwise, the frontier math benchmark is very interesting as a problem space. And someday ARC version 3, right?
I guess, are we testing the right things just because they're easy to test? Like, I mean, we're sort of obsessed with ARC because it's been unbroken for 5 years, which is cool because that's like the only thing. But like, is that even testing the right thing?
True AGI benchmark is letting your model make money on the internet.
Well, is it though? Because it's just going to be arbitraged away by other models.
Question, what could change? Like, of all the things that we learned doing ARC, the maybe rotating to verify, doing the tree, which could actually have an application and other things and maybe open new doors.
I think a direct application to many problems is difficult, but conceptual ideas should work for many problems. It depends strictly on the problem. Like if you do math questions, you could rephrase the questions. Like you can also flip like multiplications or calculations, and then you have a augmentation in mathematics space and check if the answer is still the same. You know, like somebody else asked, we are also thinking about if DFS approaches are possible in mathematics or in calculation mode.
In coding?
In coding, yeah.
Might be interesting to test, yeah.
But it's not a one-to-one translation. You have to work to get it to work. Yeah.
You said you updated a lot after 03, so do you have an updated personal definition of AGI, if you even have one?
Yeah, I mean, I still agree with Cholet that it's like adaptation to novelty. You know, it's skill acquisition, efficiency. So obviously normalize for your existing priors and experience. And by that setting, I mean, even Cholet, he would say that it has broad generality. I think that he suspects that there's dataset contamination, and for whatever reason he doesn't want to say. I think that he suspects that when he drops the new ARC version 2, that suddenly the scores will come down a lot.
But they already said it's going to be dropping down to like 30%, right?
That's what he thinks.
Oh, that's what he thinks. I thought he actually tested it.
Well, he still has access, right?
I don't know.
Yeah, I don't know if he still has access to it. But the thing is, with the dataset contamination, right? The reason why he had such a clear separation between these benchmarks is like, you know, the first time you test a frontier model on a certain test set, that's it, it's gone, data's leaked, right? So you only really get one shot at it. So he probably thinks that, you know, he's got this new set of ARC tasks now, and the first time he tests it on 03, I'm sure he thinks that it won't work very well, but then it's lost, and it's so expensive to create these tests. You know, my co-host, Dr. Duggar, he reckons that we should create like a compositional, like a, you know, recursively compositional version of ARC, you know, which means it will have some generative properties, so, you know, we can actually create novelty every single time we test. So
you and Keith had, when 01 I think came out, made the video about reasoning, the one where Lex Friedman, you remember? Yeah. So I guess one of the top complaints about that video was that just the goalposts keep moving. And the goalposts out to the Kuiper belt or something it was, I think it was a good joke. But like, what do you think that's a good thing that the goalposts keep moving? Like, or maybe the better question would be, do you think if we went back like 5 years and presented people what we have today, just the ChatGPT interface as it is today, would most people agree that it's AGI?
Well, in many senses, it kind of is. It's a jagged form of intelligence, right? So there are many things that it does very, very well, and it has some massive holes in it. I think this whole conversation with the 01 models has made us think more about what reasoning is. You know, I think I had a very binary version of what reasoning is, and actually we've come to accept that the things that language models do can be considered a form of reasoning, and there is gradations of reasoning. You know, like the more generalization you do, the more parsimonious your model is. You know, the smaller the computational circuits, if you like, the stronger the reasoning. And I don't think it's correct to say that they don't reason, because they clearly do. And there's also another thing that Sabaro Kambahati talks about, which is like, there's a lot of symbolic AI people who have this very puritanical, you know, sort of going back to Aristotle and so on, you know, like logical syllogisms and so on, you know, like only Greek reasoning is legitimate. And I think that's, I mean, there's something to be said for that. You know, like there are people who think that we should think of the world in logic, and that there are certain rules that the world conforms to, and that's correct, but it's not the only way to think about reasoning.
I think we can close on that, and yeah, thank the panel.